Welcome to Dr. Jaya's virtual school. Like Level 5 Science. Academic Week 7 Science Senses. We have 5 senses. What's that smell? Do you hear that noise? Taste this. Look at me. Feel this. Isn't it soft? When you hear or even use these phrases, you probably don't stop to think about why we use them. Well, it's because of our senses. Without us even knowing, our sense organs like nose, eyes, ears, tongue, and skin are taking in information and sending it to the brain for processing. If we did not have them, we would not be able to smell, see, hear, taste, or touch anything. Talk about a boring life then. Our senses are the physical means by which all living things can see, hear, smell, taste, and touch. Each sense collects information about the world and detects changes within the body. Both people and animals get all of their knowledge from their senses, and that is why our senses are so important. All senses depend on the working nervous system. Our sense organs start to work when something stimulates special nerve cells called receptors in a sense organ. We have 5 main sense organs. They are the eyes, nose, ears, tongue, and skin. Once stimulated, the receptors and nerve impulses along sensory nerves to the brain. Your brain then tells you what the stimulus is. For example, your sound receptors would be bombarded by billions of sound waves. When these signals reach the part of the brain they are called the cerebral cortex, we become conscious of the sounds. Sensational facts. They provide information about the body and its needs. For example, the sense of hunger shows that the body needs food. Pain, balance. Many scientists say we actually have 9 senses: sight, sound, taste, touch, smell, pain, balance, thirst, and hunger. Hearing, sight, taste, touch, and smell are known as our external senses. They provide information about the outside world. But pain, balance, thirst, and hunger are considered to be our internal senses. The most important vocabulary words of senses is cortex. Cortex is the pale gray surface layer of the brain in which information is processed. Sense is a body organ or collection of organs that informs us of some aspects of the outside world, such as odors, smell. Thalamus is a small area in the brain through which most of the information received from the sense organ passes. Sense of sight. From the moment you wake up in the morning to the time you go to sleep at night, your eyes are acting like a video camera. Everything you look at is then sent to your brain for processing and storage, much like a video cassette. This is a very simplified explanation, but as you read on, you will discover why the sense of sight is actually considered the most complex of the 5 senses. how your eyes work. Take a moment to locate an object around you. Did you know how you are able to see it? Would you believe that what you are actually seeing are beams of light bouncing off the object and into your eyes? It is hard to believe, but it is true. The light rays enter the eye through the cornea, which is a thick, transparent protective layer on the surface of your eye. Then the light rays pass through the pupil, the dark circle in the center of your eye, and into the lens. When light rays pass through your pupil, the muscle called the iris, it is a colored ring, makes the size of the pupil change depending on amount of light that's available. You may have noticed this with your own eye if you have looked at it closely in a mirror. If there is too much light, your pupil will shrink to limit the number of light rays that enter. Likewise, if there is very little light available, the pupil will enlarge to let in as many light rays as it can. Just behind the pupil is the lens, and it focuses the image through a jelly-like substance called the vitreous humor on the back surface of the eyeball called the retina. The retina, which is the size of your thumbnail, is filled with approximately 150 million light-sensitive cells called rods and cones. Rods identify shapes and work best in dim light. Cones, on the other hand, identify color and work best in bright light. Both of these types of cells then send information to the brain by way of the optic nerve. The amazing thing is, when they send the image to the brain, the image is upside down. It is the brain's job to turn the image right side up and then tell you what you are looking at. The brain does this in a specific place called the visual cortex. Protection. Because the eye is such an important and complex part of our body, we have many features which protect the eye. The eyebrows are the strips of hair above your eyes which prevent sweat from running into them. Eyelashes help keep the eye clean by collecting small dirt and dust particles floating through the air. The eyelashes also protect the eye from the sun and other light's glare. The eyelids sweep dirt from the surface of the eye. The eyelid also protects the eye from injury. Tears are sterile drops of clean water which constantly bathe the front of the eye, keeping it clean and moist. Imperfect eyesight. Not all people have perfect vision. People who can see things up close but not far away are considered to be nearsighted. Farsightedness occurs when the light that enters the eye focuses on a point behind the retina. Whether a person is nearsighted or farsighted, glasses or contacts help that person to see things much more clearly. This happens when the light entering the eye focuses on a point in front of the retina. On the other hand, people who can see far away objects but not those that are up close are frightened or farsighted. Sensational facts about sight. Most people blink every 2 to 10 seconds. Each time you blink, you shut your eyes for 0.3 seconds, which means your eyes are closed at least 30 minutes a day just from blinking. If you only had one eye, everything would appear two-dimensional. This does not work just by closing one eye. Owls can see a mouse moving over 150 feet away with light no brighter than a candle. The reason cats and dogs' eyes glow at night is because of silver mirrors in the back of their eyes called the tapetum. This makes it easier for them to see at night. An ostrich has eyes that are 2 inches across. Each eye weighs more than the brain. A chameleon eyes can look in opposite direction at the same time. A newborn baby sees the world upside down because it takes up some time for the baby's brain to learn to turn the picture right side up. 1 is every 12 males is colorblind. So understand how important is the sight. Vocabulary of sight. Colorblind, when someone cannot make out the difference between color. Cones, they are receptors that are sensitive to all the colors in the visible spectrum of light. Cornea, the clear, tough covering over the iris and pupil that helps protect the eye from damage. Farsighted, being able to see distant things clearly, but close things look blurred. Iris, muscles that control the amount of light that enters the eye. It is found between the cornea and the lens. Lens, a clear, flexible structure that adjusts the eye's focus, allowing us to see objects both near and far. It is responsible for about 20% of our focusing. Farsighted, being able to see distant things clearly, but close things look blurred. Nearsighted, only able to see things close by, and anything further away is blurred. Optic nerve, the bundle of nerve fibers that carry information from the retina to the brain. Pupil, a black spot in the middle of the eye that looks like a small black hole. Retina, the layer of light-sensitive cells lining the inside of your eye that detects images, focuses on the back of your eye. It is connected to the brain by the optic nerve. Rods, they are receptors that are sensitive to light and dark. Sclera, the white part of the eye around the iris. Vitreous humor, clear jelly-like fluid found in the back portion of the eye, maintains shape of the eye. Sense of smell. Have you ever wondered what you smell when you smell the roses in the springtime? What makes a smell is something that is too small to see with your eyeball alone. It is even too small to be seen with a microscope. What you smell are tiny things called odor particles. Millions of them are floating around waiting to be sniffed by your nose. You smell these odors through your nose, which is almost like a huge cave built to smell, moisten, and filter the air you breathe. As you breathe in, the air enters through your nostrils, which contain tiny little hairs that filter all kinds of things trying to enter your nose, even bugs. Then little hairs are called these cilia, and you can pretend that they sweep all the dirt out of the nasal cavity, which is the big place the air passes through on its way to the lungs. After passing through the nasal cavity, the air passes through a thick layer of mucus to the olfactory bulb. There are smells are recognized because each smell molecule fits into a nerve cell like a lock and key. Then the cells send signals along your olfactory nerve to the brain. At the brain, they are interpreted as those sweet smelling flowers or that moldy cheese. Our sense of smell is connected really well to our memory. For instance, the smell of popcorn can remind you of being at the movies with a friend, or the smell of tar can remind you of riding in a car to the beach. Humans have 7 primary odors that help them determine objects. Here are 7 odors: camphoric, mothballs; musky, perfume; aftershave, roses, floral; pepperminty, mint gum; ethereal, dry cleaning fluid; pungent, vinegar; putrid, rotten eggs. Dear friend, there are many sensational facts about smell. Dogs have 1 million smell cells per nostril, and their smell cells are 100 times larger than humans. Humans use insect warning chemicals called pheromones to keep away pesky insects. People who cannot smell have a condition called anosmia. If your nose is at its best, you can tell the difference between 4,000 to 10,000 smells. As you get older, your sense of smell gets worse. Children are more likely to have better sense of smell than their parents or grandparents. Vocabulary: smell. Mucus: sticky, watery material secreted from special glands that protects and lubricates delicate surfaces, including the inside of the nose. Nasal cavity: space in the skull behind the nose through which inhaled air passes on its way to the lungs. Now impulse: tiny electrical signals that carry their information in a coded form like tiny bursts of electricity inside a computer. Nostrils: either of the external opening of the nose. Olfactory organs: the organs of smell which are positioned in the top of the nasal cavity. Pheromones: chemical messengers which are produced in perspiration and cause a response in the smelling organs. Smell receptors: the structures that respond to stimuli in smell and causes a nerve impulse to be generated. Turbinates: thin shells of the bone in the nasal cavity which guide the air and direct its flow. There are other terms like nostril, opening in the nose that helps you to breathe; cartilage, what your nose is made of; olfactory nerves, nerves that tells your brain what you are smelling; taste buds, nerves of taste. The 4 taste sensations are sweet, sour, salty, bitter. The 5 touch sensations are touch, pressure, pain, hot and cold. All these are interlinked. Your smell your taste buds and your touch sensations give you the complete sense. Sense of touch. While your other four senses, that is sight, hearing, smell, and taste, are located in specific parts of the body, your sense of touch is found all over. They do this by carrying the information to the spinal cord, which sends messages to the brain where the feeling is registered. The dermis is filled with many tiny nerve endings which give you information about the things with which your body comes in contact. This is because your sense of touch originates in the bottom layer of your skin called the dermis. The nerve endings in your skin can tell you if something is hot or cold. They can also feel if something is hurting you. Your body has about 20 different types of nerve endings that all send messages to your brain. However, the most common receptors are heat, cold, pain, and pressure, or touch receptors. Pain receptors are probably the most important for your safety because they can protect you by warning your brain that your body is hurt. Some areas of the body are more sensitive than others because they have more nerve endings. Have you ever bitten your tongue and wondered why it hurt so much? It is because the sides of your tongue have a lot of nerve endings that are very sensitive to pain. However, your tongue is not as good at sensing hot or cold. That is why it is easy to burn your mouth when you eat something really hot. Your fingertips are also very sensitive. For example, people who are blind use their fingertips to read Braille by feeling the patterns of raised dots on their paper. To learn more about Braille, we should always practice it with closing the eyes. Sensational facts about touch. You have more pain nerve ending than any other type. Shivering is a way your body has of trying to get warmer. The least sensitive part of your body is the middle of your back. The most sensitive areas of your body are your hands, lips, face, neck, tongue, fingertips, and feet. There are about 100 touch receptors in each of your fingertips. Rattlesnakes use their skin to feel the body heat of other animals. Vocabulary of touch. Braille, a special alphabet for blind people made up of patterns of raised dots, and each pattern stands for a letter of the alphabet. Dermis, the skin's inner layer. Epidermis, the outer layer of the skin. Touch receptors, the structures that respond to touch stimuli and causes a nerve impulse to be generated. Sense of taste. Have you ever thought about why foods taste different? It's really quite amazing. Your tongue and the roof of your mouth are covered with thousands of tiny taste buds. When you eat something, the saliva in your mouth helps break down your food. This causes the receptor cells located in your taste buds to send messages through sensory nerves to your brain. Your brain then tells you what flavors you are tasting. Taste buds probably play the most important part in helping you enjoy the many flavors of food. Your taste buds can recognize your basic kinds of taste: sweet, salty, sour, and bitter. The salty sweet taste buds are located near the front of your tongue. The sour taste buds line the sides of your tongue, and the bitter taste buds are found at the very back of your tongue. Everyone's tastes are different. In fact, your taste will change as you get older. When you were a baby, you had taste buds not only on your tongue but on the sides and roofs of your mouth. This means you were very sensitive to different foods. As you grew, the taste buds began to disappear from the sides and roof of your mouth, leaving taste buds mostly on your tongue. As you get older, your taste buds will become even less sensitive, so you will be more likely to eat foods that you thought were too strong as a child. What if you could not taste anything? Things like medications, smoking, not getting enough of the right vitamins, injury to the head, brain tumor, chemical exposure, and the effects of radiation can cause taste disorders. Some sensational facts about taste. We have almost 10,000 taste buds inside our mouth, even on the roofs of our mouth. Insects have the most highly developed sense of taste. They have taste organs on their feet, antennae, and mouth parts. Fish can taste with their fins and tail as well as their mouth. In general, girls have more taste buds than boys. Taste is the weakest of the five senses. Vocabulary of taste. Chemical. Any substance that can change when joined or mixed with another. Papillae. Bumps on the tongue that include groups of cells that sense taste. Taste buds. Parts of the tongue with sensors to taste food. Tongue. The muscle in the mouth that aids in tasting food. Sense of hearing. Like your other sense organs, your ears are extremely well designed. You are probably able to figure out that your ears help you to hear sounds, but what you probably did not know is that your ears also help you to keep your balance. In fact, they serve two very important purposes. Do you know what they are? How you hear. When an object makes a noise, it sends vibrations, that is, sound waves, speeding through the air. These vibrations then funneled into your ear canal by your outer ear. As the vibrations move into your middle ear, they hit your eardrum and cause it to vibrate as well. This sets off a chain reaction of vibrations. Your eardrum, which is smaller and thinner than the nail on your pinky finger, vibrates the three smallest bones in your body. First the hammer, then the anvil, and finally the stirrup. The stirrup passes the vibrations into a coiled tube in the inner ear called the cochlea. The fluid-filled cochlea contains thousands of air-like nerve endings called cilia. When the stirrup causes the fluid in the cochlea to vibrate, the cilia move. The cilia changes the vibrations into messages that are sent to the brain via the auditory nerve. Auditory nerve carries messages from 25,000 receptors in your ear to your brain. Your brain then makes sense of the messages and tells you what sounds you are hearing. How you keep your balance? Near the top of the cochlea are three loops called the semicircular canals. The canals are full of liquid also. When you move your head, the liquid moves. It pushes against hair-like nerve endings which send messages to your brain. From these messages, your brain can tell whether or how your body is moving. If you have ever felt dizzy after having spun around on a carnival ride, it was probably because the liquid inside the semicircular canal swirled around inside your ears. This makes the hairs of the sensory cells bend in all different directions, so the cell signals confuse your brain. What did you say? Did you know that some people have trouble hearing and others cannot hear at all? Well, it's true. When a person cannot hear well, a hearing aid can sometimes help them hear better. However, people who are entirely deaf have to rely on all their other senses to help process of all the information from the world around them. They are deaf because of an illness or they were born that way. You can also lose your ability to hear at an early age by listening to things that are very loud. Scientists measured loudness in decibels. Here is a table with noises and the decibel levels. Noise in decibels. Whisper 20, normal talking 50 to 60, car traffic 70, alarm clock 80, lawn mower 95, rock concert 100, jackhammer 150, jet engine 130 and gunshot 140. Sensational facts about hearing. Babies can get earaches because of milk backing up in the chain tube, which causes bacteria to grow and may cause hearing problems later in life. When you go up to high elevations, the change in pressure causes your ears to pop. Children have more sensitive ears than adults. They can recognize a wider variety of noises. Dolphins have the best sense of hearing among animals. They are able to hear 14 times better than humans. Animals hear more sounds than humans. An earache is caused by too much fluid putting pressure on your eardrum. Earaches are often the result of an infection, allergies, or virus. Vocabulary of hearing. Anvil, one of the three bones of the middle ear that helps transmit sound waves from the outer ear to the cochlea. It is also called the incus. Auditory nerve, nerve that transmits signals from the cochlea to the brain. Cochlea, shaped like a snail shell, this organ of the inner ear helps transmit hearing signals to the brain. Decibel, a unit of measuring the loudness of a sound. Ear canal, tunnel in the middle ear that funnels sound from the outer ear to the eardrum. Eardrum, membrane separating the outer ear from the inner ear. It is also called the tympanic membrane. Hammer, one of the three bones of the middle ear that helps transmit sound waves from the outer ear to the cochlea. It is also called the malleus. Semicircular canals, three tubes in the inner ear that control balance. Stirrup, one of the three bones of the middle ear that helps transmit sound waves from the outer ear to the cochlea. It is also called the stapes. Welcome to Dr. Jaya's virtual school. Like Level 5 Science, Academic Week 8 Science, Earth Water. Here are few terms and definitions which are used in earth water. Aqueduct, a channel where water travels from place to place. Aquifer, layers of rock and soil that allow water to flow through. Condensation, the process in which gas changes to liquid. Conservation, the act of saving water. Contaminate, to make water dirty or polluted. Reclamation, the act of recycling used water. Reservoir, water from a river that builds up behind a dam. Water cycle, the continuous movement of water between Earth's surface and the air. Watershed, a place where water drains into a specific body of water. Measuring, how you can determine the size, distance, time, volume, area, mass, weight or temperature. Clouds, what forms when water vapor in the air changes into a liquid. Rain, a form of non-frozen precipitation. Snow, a form of frozen precipitation. Evaporation, the process in which the water changes from a liquid to gas. Oceans, cold salt water. Fresh water comes from ice caps, glaciers and aquifers. Groundwater. Groundwater fills the open spaces in rocks, sediment and soil beneath the surface. Groundwater is an important source for domestic, industrial and agriculture use, but is also an important emotional agent, an important energy source in some areas. Groundwater and the hydrologic cycle. Groundwater is about 22% of the world's fresh water. Comes from precipitation percolating through soils and sediment. Streams, lakes and snowmelt also contribute. What properties of Earth's materials allow them to absorb water? Porosity. Porosity means the percentage of a material's volume that is pore space. Permeability, the measure of the interconnectedness of pore spaces. Aquifer, permeable layer that transports water. So these are the three main properties of earth materials that allow them to absorb water. What is the water table? Zone of aeration means pore spaces contain mostly air. Zone of saturation, the pore spaces contain mostly water. And water table means the top of the zone of saturation. So it is very important to understand these three: zone of aeration, zone of saturation and water table. How does groundwater move? Gravity moves groundwater just as it does water in channels. It moves from areas of high pressure to areas of low pressure. It may move up to 250 meters per day or less than a few centimeters a day. What are springs? Places where groundwater flows or seeps out of the groundwater. When percolating, water reaches the water table or impermeable layer. It flows laterally and may intersect the surface. So all these things cause springs. What are water wells? Water percolates into a drilled or dug hole when the zone of saturation is penetrated. Pumping can create a cone of depression. Lowering the water table is a major problem in some areas. So these are water wells where you pump and get the water out. What are artesian systems? Artesian systems are confined groundwater that flows at the surface under hydrostatic pressure, called confined above and below. Rocks are exposed at the surface and sufficient precipitation to recharge the aquifer. How does groundwater erode and deposit material? When soluble rock is exposed at the surface, water can attack minerals chemically and become a significant erosional agent. Sinkholes and karst topography. Sinkholes form when soluble rock is dissolved, leaving shallow depressions. Cavern roof collapse. Karst topography. Numerous caves, springs, solution valleys, sinkholes, and disappearing streams. All this deposit material. What are caves and cave deposits? Caves form as a result of dilution of carbonate rocks. They may have a complex history reflecting changes in the water table. So this dissolution makes caves and cave deposits. Depositional features include dripstone, stalactites, and stalagmites. Lowering the water table occurs primarily when more groundwater is used than is replaced by natural processes. The High Plains aquifer is used for agriculture. Water is being used at up to 100 times its recharge rate in some areas. Saltwater incursion. Excessive pumping in coastal areas can result in salt water being drawn into wells. Major problem in rapidly growing coastal communities, and recharge wells are often used to pump water back into the system. What is subsidence? Loose grains of the aquifer are packed tighter after groundwater withdrawal. So subsidence of the land has lowered Mexico City more than 3 meters in some places. How does groundwater contaminate? What is groundwater contamination? Most common sources are sewage, landfills, toxic waste disposal sites, and agriculture. It is a serious problem due to discriminate practices by industry and citizens. Here is some hydrothermal activity. What is it and where does it occur? It occurs in hot springs. Hot springs are water is circulated deep where it is heated by magma or cooling igneous rocks. It runs freely at the surface, and geysers forcefully eject water and steam because of contractions in the plumbing system. What is geothermal energy? About 1 to 2% of the world's energy is generated from geothermal sources. It is limited to locations with plentiful water and where hot rocks are near the surface. Iceland, United States, Mexico, Italy, New Zealand, Japan, Philippines, and Indonesia have this geothermal energy. The Pearl, a rotating restaurant built on the top of the Reykjavik geothermal water tanks. So, understand the geothermal energy is very important. Here are some definitions for earth water, which is very important. Groundwater, water in the zone of saturation. Porosity, the space between solid particles of soil or rock that can be filled by fluids. Permeability, the ease with which fluids can pass through a body of soil or rock. Infiltration, the movement of water from the surface into the ground. Aquifer, a body of soil or rock that can hold a usable amount of water. Aquiclude, a body of soil or rock that blocks the flow of water. Here is Darcy's law. Just as streams have a discharge, so do aquifers. For example, Q is equal to KIA. Q is the discharge of the aquifer, K is the permeability of the aquifer, I is the hydraulic gradient, and A is the cross-sectional area of the groundwater is passing through. Ogallala, High Plains aquifer, buried erosional remnant of Rocky Mountains, largest single water bearing unit in North America, holds enough water to fill Lake Huron. Ogallala aquifer depletion is most water pumped for irrigation of crops principally used to feed livestock. From 1940 to 1980, aquifer water table fell an average of 10 feet a decade. In 1980, only fell another foot due to improved irrigation techniques. So this is about the groundwater. Water spouts. How do you read a water spout? F1 40 by 48 mile winds, not much damage, a water spout is read. Or F2 54 to 62 mile winds, simple damage. F3 65 to 73 miles winds, moderate damage. F4 85 4 to 94 miles winds, severe damage. And F5 108 to 123 mile winds, devastating damage. And F6 388 to 398 mile winds, you hope no one is around. So such devastating takes place when there is a water spout too. So how are water spouts made? Water spouts are sometimes made after a hurricane. Water spouts are a bunch condensed water droplets. Water spouts are vortexes. Wind helps water spouts navigate through a coast. Are water spouts helpful? No and yes, both. Water spouts are not helpful when they rip up towns and cities that are by a coast. Or water spouts are helpful when they throw fish onto the shore. But still, they hurt more than they help. So what are normal water spout victims? Usually sea sponge, fish, seahorse, walrus and manatee. So be careful and always be away from the water spot. The moment you see a water spot, run away from there. Whirlpools. There are whirlpools in the rivers or in the seas too. You have to be very careful. There are famous whirlpools like Corrie Brecon of the coast of Scotland, Mox Truman of the coast of Norway, Saltstraumen of the Norway, also in the middle of New Brunswick and Maine. But there are many small whirlpools here and there in almost every river. You have to be careful. Where do whirlpools occur most? Whirlpools occur most under bridges, in the middle of the ocean, in outer spaces. But to put it simple, Japan, USA and China have more whirlpools. How is a whirlpool started? Whirlpools at sea are caused by the meeting of opposing currents and tides, by ocean currents striking offshore rocks and other coastal configurations, and by the force of wind acting upon water. Irregularities in basin and channel bottoms usually cause whirlpools in rivers and lakes. Whirlpools in the open seas are giant suctionless eddies such as the Sargasso in the Atlantic Ocean, were sometimes becalmed in them and were held fast in their centers or were swept by the slowly rotating currents against rugged coasts. Whirlpools with a strong vertical motion, on the other hand, can become very violent and are capable of sucking boats into their rapidly down-spiraling cavities. Noted whirlpools include the Charybdis in the Strait of Messina between mainlands Italy and the island of Sicily, the Maelstrom or Moxie strata in the Lofoten Islands of Norway, and the Whirlpool Rapids below Niagara Falls. Erosion. In erosion, we have topics like mass movements, running water, glaciers, and wind. Mass movements are caused from gravity, occur on steep slopes, and increase with rainflow. Slump. Steep slopes, material underneath has weakened. Creep. Small sediments are pushed up during freezing and slide down when thawed. Rock slides, large blocks of rock breaking loose from steep slopes. Mud flows. Add a strong statement that summarizes how you feel or think about this topic. Summarize the key points you want your understand and remember about mud flows, creep and everything, and write about all of them. Climate change, floods and droughts. In earth water, climate change is very important. Climate change is when the climate is altered over time for a long time as a result of human or natural influences. There are many examples of effects of climate change, such as a rise in sea level during the past century from 4 to 8 inches, an increase in precipitation by approximately 1%, changes in the ecosystem, altering the amount of snow in the north a rise from 5 to 10% in rainfall, and summers becoming increasingly dry while ice in the Arctic Ocean decreases. Climate change can bring positive changes such as its effect on extending the growing season in areas with short seasons, but when change comes quickly, living systems don't have time to adapt. Global warming. Global warming is the increase of the Earth's surface median temperature over time. Since late in the 19th century, the average global surface temperature has gone up 5 degrees Fahrenheit, and during the 20th century, surface temperatures grew by about 1 degree Fahrenheit. Predictions for the next 100 years are for a 2.7 to 8 degree Fahrenheit increase, depending on how much fossil fuels are burned and forest systems are removed. An increase in greenhouse gases is the cause of global warming. Some effects include an increase in sea level, difficulties in agriculture, change in rainfall, and changes in the ecosystem, which will cause animals and plants to have to adapt or perish. Global temperature graph. The effect of floods. Higher surface temperatures and changes in precipitation cause floods in some places and droughts in others. Floods. A rise in sea level and severe rain are two causes of floods. Long-term changes in the hydrological cycle due to higher temperatures contribute to more floods. More water vapor in the atmosphere, because the atmosphere is heating up, can cause floods to happen more regularly. Floods. Sea level rising will also contribute to more floods. The sea level is predicted to go up from 4 inches to 3 feet. Sea level rises when the water warms and increases in amount, or when glaciers and ice melt. As the glaciers and ice turn into water, the sea level increases and floods could start to last for a longer amount of time and happen more frequently. The hydrological cycle. Examples of predictions of flooding. There are predictions that as a result of climate change, there will be a large increase in famine by 2050 of 30 million people going hungry because of less crops caused by the flooding. One country that suffers from flooding because of climate change is Bangladesh. They experienced major flooding in 1998, in which 2/3 of the country was underwater. There are predictions for this to become worse with more constant flooding and more of the country underwater by 2100 if it continues the same way. Many coastal cities could be affected, including Manhattan, San Francisco, New Orleans, and Miami, and cities around the world, including highly populated ones like Shanghai. Bangladesh is near India, so we have to be careful that the Indian subcontinent should not get affected. The effect on droughts. There will also be more droughts as a result of global warming and climate change. The period of time during which droughts last will also be increased. The changing in the hydrological cycle causes changes in precipitation. Some places get wetter, others drier. When there is a buildup of water vapor in the atmosphere, because the atmosphere is heating up, or very sudden changes in climate, droughts happen more regularly. Examples and predictions of drought. Droughts like floods could also cause famine because they ruin crops. An example of droughts as a result of climate changes are the droughts in Africa. For example, at the base of Mount Kilimanjaro, there is becoming a very limited water supply. Africa is also very sensitive to any temperature change, which causes droughts to come more easily. In February and March 2005, there were droughts in Zimbabwe, Mozambique, Malawi, Zambia, and Namibia. The droughts lasted for about 4 to 8 weeks. So you should understand, here are some maps of droughts. So floods or droughts, everything is because of the earth's water. So dear friend, take care of earth's water and always pray river god and water god Varuna to help all of us. Welcome to Dr. Jaya's virtual school. Loic, level 5, science. Academic week 9, science, earth's weather. Earth's weather. Weather concepts. Atmospheric pressure. Atmospheric pressure. The Earth's atmosphere exerts a pressure that decreases with the distance above Earth's surface, and that at any point it exerts this pressure equally in all directions. Solar system you learnt about. The sun is made of helium and hydrogen. The sun is the largest thing in our solar system. The 9 planets orbit the sun because of the gravitational attraction between them. What is air pressure? Air pressure is the force put on you by the weight of air molecules. You know that air molecules are invisible, but they still have weight to take up space. The air molecules are pushing against your body right now. Do you think the force, how hard they are pressing, is greater pressing down on the top of your head, greater pressing on the sides of your body, or equal in all directions? So do this experiment and understand whether air pressure is hard. What is the atmosphere? The atmosphere is the air that surrounds the earth. We live at the bottom of a sea of air. The higher you go in the atmosphere, the less air molecules there are in the sea of air. If there are less air molecules, does that mean the air pressure increases or decreases as you go higher? If it increases, it is more. If it decreases, it is less. Why don't I feel the pressure? The reason you don't get squished by the pressure of the atmosphere is because you have air inside your body. The air inside your body is the same as the pressure on the outside. When you drive up the mountains, what happens to your ears? when the air inside your body changes so that it will be the same as the new pressure outside your body, or your ears pop. Your ears pop because the air pressure is different as you go higher through the mountains. Try this. A balloon filled with air can't release the air inside as it goes higher, like we can. What do you think would happen to a balloon as it rises higher and higher in the air? Remember, the air outside the balloon will have less pressure as it gets higher. Wind, where does it come from? Wind, where does it come from? You know, uneven heating of earth causes air movements, convection currents. The earth atmosphere pressure, which you have learned, that earth's atmosphere pressure, what is true about it? Air pressure pushes more on the side than on the top. Air pressure pushes more on the top than on the side of your body. Air pressure pushes against your body equally from all directions. What is important here? Which is important? Understand it, experience it, and then answer it. The higher up in the atmosphere you go, the air pressure increases or decreases, whether it is more or less. Find out as you experience it in the garden. So what is current? You have already learned whether we live at the bottom of a sea of air. Just like water in a river, the air around us moves. This movement is called a current. A current is a flow of water, air, or gas. So what causes the current of air to move? The heat that comes from the sun shining on the earth. So how does that work? The sun heats the earth's surface. The air that is near the surface begins to get warmer. As the air gets warmer, the air molecules move further away from each other. So here, warm air molecules are spread apart. They are less dense and light. And cold air molecules are close together. They are more dense and heavier. So this means the warm air is less dense or lighter, so it floats up. The higher it goes, the colder it gets, and the air begins to cool off. As it cools off, it begins to sink back down again because it is denser or heavier. The air in our atmosphere is constantly moving. This cycle of air molecules moving up and down is what causes wind. So what is convection current? You know what it is warmer at the equator than at the poles because Earth is tilted. So the sun shines more at the center, the Earth, that is the equator, than at the top and bottom, that is the poles. The warmer, lighter air at the equator moves towards the cooler air at the poles. The cold, heavy air at the poles moves towards the equator. So this causes a constant river of air movement called convection currents. Here, this picture shows you the flow of convection current. They go around and around and around, constantly moving the air in our atmosphere. Why are some days windy and some days not windy? Because when two convection currents meet, it causes the wind to blow. Think of two streams of water that come together. The water bubbles and splashes more where the two streams meet. Streams of air, convection currents are similar. Discover why some days are wider than others by using the weather machine. Experiment with the different temperatures. What do you notice about the wind? How do you make a strong wind? Experiment it. Water cycle. Water cycle, when liquid water evaporates, it turns into water vapor in the air and can reappear as a liquid when cooled or as a solid if cooled below the freezing point of water. Water vapor in the air moves from one place to other and can form fog or clouds, which are tiny droplets of water or ice and can fall to earth as rain, hail, sleet, or snow. Here the wind, which you learned about wind and convection currents. When two currents come together, it makes wind. If one current is very cold and the other current is very hot, what happens? It creates a very gentle breeze, or it creates a mild wind, or it creates a very strong wind. Understand this and answer. Which of these is true? Colder air rises up and warm air sinks down, or warm air rises up and colder air sinks down? How old is your water? Understand. Did you know that the water that comes out of our water fountains is the same water that dinosaurs splashed in as they waded through lakes and rivers? How is that possible? Just see, there is no new water. It is the same water, gets dirty, gets purified, goes up into the clouds, comes down as the rain, and again gets into it. So the water goes on. So what is a cloud? A cloud is made of tiny water droplets or ice crystals that are in the air. If the droplets become large enough, they may be visible as a cloud or fog. Where do the droplets come from then? So, where do the droplets come from? This is similar to the way you separated salt from water. Do you remember that? How you separated salt from water? Where is all the water then? Now you know how Earth's water goes in a circle from liquid to gas back to liquid again. Where is the air? In rivers and lakes, oceans, and as a solid in glaciers. So where is the most of the Earth's water? Glaciers, rivers and lakes, and our oceans. Think it over and answer. So this graph shows you where all the Earth's water can be found. There is not much for us to drink. So let us see. Only 1% of all Earth's water is drinkable. You can drink only 1% of water. 2% of water is frozen in glaciers, and the other 97% is found in the ocean. So what is severe weather then? Severe weather is causes and effects of different types of severe weather. Let us understand what it is. Let us again understand about the water cycle. You learned about Earth's water. What percentage of Earth's water is fresh water? Whether it is 1%, 2% or 97%. Think it over. Just now we have understood. And which of these is not a source of fresh water? River, lake or ocean? Think it over. Which of these in the correct order of the water cycle? Evaporation, precipitation, collection and condensation, or evaporation, condensation, precipitation and collection, or evaporation, precipitation, condensation or collection. Understand the cycle. Go back, see the cycle and understand. When ocean water evaporates, it becomes what? Precipitation or water vapor. Once we understand this, then we will know what is severe weather. Extreme or severe weather is simply really bad weather or weather on a large, more serious and devastating scale. For example, instead of a few snowflakes falling, there is a snowstorm and snow drifts can be many meters deep. So this will be an extreme forms of a windy day, includes gales, hurricanes and tornadoes. Heavy rain may last much longer than a few hours or even days and result in flooding of rivers, roads and homes. So extreme weather events may not happen very often. When they do, they can cause destruction of buildings, vehicles, roads and homes, costing many billions of pounds. People's lives are also at risk from some unexpected weather events. So modern technology allows predictions to be made so people know when and where a hurricane is going to hit land. However, some storms, including tornadoes, still cannot be forecast accurately. So what are some examples of severe weather? Hurricanes, tornadoes, thunderstorms and blizzards are all types of severe weather. If so, what is a hurricane? A hurricane is a big storm that forms over the ocean. Hurricanes form over warm parts of the Atlantic Ocean and the Pacific Ocean. They form near the equator in the tropical zone. Due to modern warming systems, the number of deaths from hurricanes is now lowered. So what are the causes of hurricane? Warm, wet mass of air over the sea that begin to evaporate. Water has to be 79 degrees or warmer. Combined actions of air, water and heat produce a huge spinning system of clouds, rain and wind. The effects are rain causes floods, thunderstorms are produced, wind smashes everything in its path. The most dangerous part of a hurricane is the wind causes ocean waves to rise over the land. These waves can reach 30 feet in height. What are the types of hurricanes? Hurricanes are measured in 5 categories on the Saffir-Simpson scale. What are they? Category 1, minimal. So the wind speeds will be of 74 to 95 meters per hour. Category 2, moderate. Wind speeds of 96 to 110 mph. Extensive, wind speeds will of 111 to 130 mph. Extreme, wind speeds will be 131 to 155 mph. And catastrophic, wind speeds of over 155 miles per hour. So what should be the safety tips to encounter these extreme severe weather? Listen to TV or radio for weather bulletins. Board up garage and porch doors and stay away from windows. Leave home if you might be affected by storm tide or flooding. Follow evacuation routes to nearest shelter. Turn off electricity and water. Fill containers including bathtub with several days of drinking water. Turn up refrigerator to maximum cold but don't open it if not necessary. Use phone only for emergencies. Facts about hurricanes. Diameter of the eye can be 12 to 125 meters across. Other names of hurricane are also cyclone and typhoon. Hurricane season lasts from June 1st to November 30th. Names are chosen from an alphabetical list of alternating male and female names. The National Weather Service started using men's names in 1979. So let us understand what is a tornado. A tornado is a funnel-like storm of strong winds. The United States gets about 1,000 tornadoes a year. Causes: formed by instability in the atmosphere, usually formed during thunderstorms. A downward flow of cold air from clouds meets a rising flow of warm air from the ground. When the conditions are just right, a tornado will start. Effects: houses are destroyed, people and animals can be killed, crops are destroyed, diseases can spread, water gets contaminated, communities are demolished and must be rebuilt. So the types of tornadoes are, they are categorized as F4, F5 on the Fujita person scales. F4 is light, F1 is moderate, F2 is considerable, F3 is severe, F4 is devastating, and F5 is incredibly powerful. There are 10 types of disasters took place because of the tornadoes. In 1925, in this you can find it: Illinois, Indiana, 689 people died. Louisiana, Mississippi, Missouri, Mississippi, Georgia, Texas, Louisiana, Wisconsin, Missouri in America, because a lot of tornadoes takes place in America. The safety tips are: seldom, very less in India, but still we have to also be careful, because we never had tsunami, but now we had tsunami, so we have to be careful. So safety tips are: stay calm, look for safe shelter like a basement, small closet or bathroom. Stay away from the windows, the broken glasses can cause injuries. Listen for reports on a portable radio. Keep a weather radio with batteries if you live in an area with lots of tornadoes. Protect your body with a mattress or blankets. Evacuate mobile homes and find shelter in a solid structure. If you are out in the open, find a ditch or overpass to hide in. Facts about tornado. Tornado came from the Spanish word tornada. Other names are twisters or cyclones, characterized by rapidly rotating columns of air hanging from cumulonimbus clouds. At ground level, they usually leave a path of destruction only about 50 miles wide and travel an average about 8 to 24. Lightning. What causes lightning? A thunderstorm is a weather pattern that includes thunder, lightning, and usually rain or hail. It can lead to tornadoes. The basic need for thunderstorms is warm, moist air, so they happen most often in the tropical areas. Overland, thunderstorms strike more often in the afternoon and early evening, since the ground heats up from the sun during the day. They occur more frequently on hot summer days than in cold weather. Causes of thunderstorms. Moist air heated by the sun rises, which causes an updraft of air. As warm air rises, water in the air forms clouds. When water vapor in the cloud gets too heavy, it falls as rain. Conflict between the warm updraft of air and cool water in the clouds causes thunder and lightning. The severity of the thunderstorm depends on the difference in temperature. What causes lightning? In a cloud, swift air separates water droplets, causing electrical charges. The electrical charges build up and causes huge electric shocks. It generates about 100 million volts of electricity. What causes thunder? Lightning causes thunder. When lightning strikes, it superheats the air around it. This causes a shock wave, kind of like throwing a rock into water. The ripples cause sound as they travel through the air. Types of lightning. Heat. Lightning from storms that are so far away that we cannot hear the thunder or see any rain. Sheet. Lightning that covers a wide area and can be inside or between clouds. Forked. Bolts that most commonly occur between clouds and the earth. Ball. A very rare type, it is pear-shaped that glows and moves slowly. It appears to come from a storm cloud and can last 5 seconds. So these are different types of lightning. Types of thunderstorms. Single cell, a single isolated thunderstorm. Multi-cell, cluster or ray line. A line of thunderstorms that feed and contribute to each other. Supercell, a very dangerous storm that can lead to tornadoes. Safety tips, do's and don'ts. Do's: if you are outside, go into your house, large building or car, any body of water, tractors and all farm equipment, railroad tracks, open areas. Find a ditch or bridge and take shelter. You must stay outside, stay away from trees, metal pipes, wire, clotheslines and fences. Don't use the telephone except emergencies. Don't go into any small buildings. Don't go under any large trees. Don't be taller than your surroundings. Don't stand on a hilltop. Don't go out in a boat. Don't carry anything made of metal. Don't be near large metal objects. So, there are some interesting facts about thunderstorms. Thunderstorms are local weather disturbances. They usually affect only few square miles. A single thunderstorm usually lasts only 30 to 40 minutes. A dying thunderstorm can trigger another thunderstorm. Lightning strikes the earth about 100 times per second. The energy released by a thunderstorm is thought to be larger than the explosion of an atomic bomb. About 100 Americans are killed each year by lightning. The dark color of clouds in thunderstorm is caused by water accumulation. There are thunderstorms even in India. We have to be careful. Interesting facts about thunderstorms. Thunderstorms are local weather disturbances. They usually affect only a few square miles. A single thunderstorm usually lasts only 30 to 40 minutes. A dying thunderstorm can trigger another thunderstorm. Lightning strikes the earth about 100 times per second. The energy released by a thunderstorm is thought to be larger than the explosion of an atomic bomb. About 100. Now, these are the things which we have to understand. So all this is a bizarre situation. So what is a bizarre situation? Snow is one of the most exciting weather events that can occur during the winter months. The extreme weather version of a few flakes of snow is a snowstorm called a blizzard. Northern regions of America, Europe and Asia have learned to live with extreme snow conditions during the winter months. It is often places not used to such conditions that are worse affected. In general, the United Kingdom is one country caught out by unexpected snowstorms, largely because they are so rare. So in blizzard conditions, heavy snowfall is accompanied by strong winds and visibility is often near zero. Known as a whiteout, the winds can blow snow across land, creating large snow drifts capable of blocking roads and completely covering trains and cars, trapping people inside. Communications and transport can be severely affected in both cities and the countryside. The worst snowstorm disaster was on the east coast of North America from March 12th to 13th, 1993. This storm has been called the storm of the century, with 40 inches of snowfall in the New York State and 60 inches in the mountains along the Tennessee-North Carolina border. Winds of 70 miles per hour were frequent throughout the affected area, with snow drifts up to 20 feet high. 500 people lost their lives due to the severity of the storm and the large area affected. Damage cost reached 1.2 billion. We all have experienced an icy morning when windscreens need defrosting and road surfaces can have icy patches. When I was there in America, I could see this, experience this. Freezing rain, however, can create some very different hazardous conditions. If snowflakes melt as they fall but do not have the time to refreeze, they will freeze to whatever surface they hit as long as it is cold enough. Ice storms are a result of heavy freezing rain and usually occur with big winter storms and big temperature changes. Everything is covered with a layer of ice up to 5 centimeters thick. Even thin ice can be heavy, and tree branches, power lines and electricity pylons are frequently damaged. Weather maps and prediction. How do we do weather maps and prediction? How to use weather maps and data to predict local weather and know that weather forecasts depend on many variables. What is a weather map? Weather maps are maps that show that the weather is in a certain place. It can show many different things like temperature, wind directions, storms and other things. What do the H's and L's mean? The H's are high pressure systems and the L's are low pressure systems. High pressure systems usually bring nice sunny weather. Low pressure systems usually bring stormy weather. What are the blue and red lines? The blue lines are cold friends and the red lines are warm friends. The wind pushes them so that they move from place to place. They are called friends because as they move, they change the weather that is in front of them. For example, the weather on Monday is warmer and sunny. A cold front moves into Bakersfield Monday night. It changes the weather so that Tuesday it is cloudy and cold. So, how do they predict weather then? People who report and predict the weather are called meteorologists. They use satellite images and other information to watch the weather patterns of the earth. The weather in the US moves from the west to east, so if it rains in Bakersfield today, then they can predict that there will be rain to the east of us tomorrow. These prevailing winds are called westerlies. Can you explain why they would be called westerlies? Understand, because it flows from west. Same thing in India, we have the monsoons. We call it as monsoons. Welcome to Dr. Jaya's virtual school. Like level 5 science. Academic week 10 science. Solar system. What is the solar system? The solar system is made up of all the planets that orbit our sun. In addition to planets, the solar system also consists of moons, comets, asteroids, minor planets, and dust and gas. Everything in the solar system orbits or revolves around the sun. The sun contains around 98% of all the material in the solar system. The larger an object is, the more gravity it has. Because the sun is so large, its powerful gravity attracts all the other objects in the solar system towards it. At the same time, these objects, which are moving very rapidly, try to fly away from the sun outward into the emptiness of outer space. The result of the planets trying to fly away at the same time that the sun is trying to pull them inward is that they become trapped halfway in between. Balanced between flying towards the sun and escaping into space, they spend eternity orbiting around their parent star. How did the solar system form? This is an important question and one that is difficult for scientists to understand. After all, the creation of our solar system took place billions of years before there were any people around to witness it. Our own evolution is tied closely to the evolution of the solar system. Thus, without understanding from where the solar system came from, it is difficult to comprehend how mankind came to be. Scientists believe that the solar system evolved from a giant cloud of dust and gas. They believe that this dust and gas began to collapse under the weight of its own gravity. As it did so, the matter contained within this could begin moving in a giant circle, much like the water in a drain moves around the center of the drain in a circle. At the center of this spinning cloud, a small star began to form. This star grew larger and larger as it collected more and more of the dust and gas that collapsed into it. Further away from the center of this mass, where the star was forming, there were smaller clumps of dust and gas that were also collapsing. The star in the center eventually ignited, forming our sun, while the smaller lumps became the planets, minor planets, moons, comets, and asteroids. A great storm. Once ignited, the sun's powerful solar winds began to flow. These winds, which are made up of atomic particles being blown outward from the sun, slowly pushed the remaining gas and dust out of the solar system. The solar system is the sun and the bodies orbiting it, the sun and all the planets, satellites, asteroids, meteors and comets that are subject to its gravitational pull. Planets are spherical objects which orbit a star. Planets can vary greatly in size, although they are never larger than the star they orbit. Planets can be rocky or gaseous. Smaller planets tend to have solid surfaces, while larger planets are balls of mostly gas. There are 8 planets known to orbit the Sun. The Sun, our solar system star, the Sun has inspired mythological stories in cultures around the world, including those of the ancient Egyptians, the Aztecs of Mexico, Native American tribes of North America, the Chinese and Indians, and also others. A number of ancient cultures built stone structures or modified natural rock formations to observe the sun and moon. They charted the seasons, created calendars, and monitored solar and lunar eclipses. These architectural sites show evidence of deliberate alignment to astronomical phenomena: sunrises, moonrises, moon sets, even stars or planets. The Sun is the closest star to Earth at a mean distance from our planet of 149.60 million kilometers, that is 92.96 million miles. This distance is known as an astronomical unit and sets the scale for measuring distances all across the solar system. The Sun, a huge sphere of mostly ionized gas, supports life on Earth. It powers photosynthesis in green plants and is ultimately the source of all food and fossil fuel. The connection and interactions between the Sun and Earth drive the seasons, ocean currents, weather, and climate. Planets. Mercury. Mercury's elliptical orbit takes the small planet as close as 47 million kilometers and as far as 70 million kilometers from the Sun. If one could stand on the scorching surface of Mercury when it is at its closest approach, the Sun would appear almost 3 times as large as it does when viewed from Earth. Temperatures on Mercury's surface can reach 430 degrees Celsius. Because the planet has no atmosphere to retain that heat, nighttime temperatures on the surface can drop to minus 170 degrees Celsius. Because the Mercury is so close to the Sun, it is hard to directly absorb from Earth except during twilight. Mercury makes an appearance indirectly, however 13 times each century. Earth observers can watch Mercury pass across the face of the Sun, an event called a transit. Observers can look into it, but only 13 times in a century. These rare transits fall into several days of May 8th and November 10th. The first two transits of Mercury in the 21st century occurred in May 2003 and November 2006. The next transit will occur on May 9, 2016. Venus. At first glance, if Earth had a twin, it would be Venus. The two planets are similar in size, mass, composition and distance from the Sun, but there are similarities end. Venus has no ocean. Venus is covered by thick, rapidly spinning clouds that trap surface heat, creating a scorched greenhouse-like world with temperatures hot enough to melt lead and pressure so intense that standing on Venus would feel like the pressure felt 900 meters deep in Earth's oceans. These clouds reflect sunlight in addition to trapping heat. Because Venus reflects so much sunlight, it is usually the brightest planet in the night sky. Earth. Earth, our home planet, is the only planet in our solar system known to harbor life that is incredibly diverse. All of the things we need to survive are provided under a thin layer of atmosphere that separates us from the uninhabitable void of space. Earth is made up of complex interactive systems that are often unpredictable. Air, water, land and life, including humans, combine forces to create a constantly changing world that we are surviving to understand. Viewing Earth from the unique perspective of space provides the opportunity to see Earth as a whole. Scientists around the world have discovered many things about our planet by working together and sharing their findings. Some facts are well known. For instance, Earth is the third planet from the Sun and the fifth largest in the solar system. Earth's diameter is just a few hundred kilometers larger than that of Venus. The 4 seasons are a result of Earth's axis of rotation being tilted more than 23 degrees. Earth's moon. The regular daily and monthly rhythms of Earth's only natural satellite, the moon, have guided timekeepers for thousands of years. Its influence on Earth's cycles, notably tides, has also been charted by many cultures in many ages. More than 70 spacecrafts have been sent to the moon. 12 astronauts have walked upon its surface and brought back 382 kilos, that is 842 pounds of lunar rock and soil to Earth. The presence of the moon stabilizes Earth's wobble. This has led to a much more stable climate over billions of years, which may have affected the course of the development and growth of life on Earth. On the side picture of the false colors show the moon's soil and mineral composition. Tranquilities, that is the May tranquilities, the Sea of Tranquility is the dark blue region on the right. Mars. The red planet Mars has inspired wild flights of imagination over the centuries as well as intense scientific interest. Whether fancied to be the source of hostile invaders of Earth, the home of a dying civilization, or a rough and tumble mining colony of the future, Mars provides fertile ground for science fiction writers based on seeds planted by centuries of scientific observations. We know that Mars is a small rocky body once thought to be very Earth-like. Like the other terrestrial planets, Mercury, Venus, and Earth, its surface has been changed by volcanism, impacts from other bodies, movements of its crust, and atmospheric effects such as dust storms. It has polar ice caps that grow and recede with the change of seasons. Areas of layered soils near the Martian poles suggest that the planet's climate has changed more than once, perhaps caused by a regular change in the planet's orbit. Martian tectonism, the formation and change of a planet's crust, differs from Earth's, where Earth tectonics involves sliding plates that grind against each other or spread apart in the sea floors. Martian tectonics seem to be vertical, with hot lava pushing towards through the crust to the surface. Periodically, great dust storms engulf the entire planet. The effects of these storms are dramatic, including giant dunes, wind streaks, and wind-carved features. Jupiter, the most massive planet in our solar system, with 4 planet-sized moons and many smaller moons, Jupiter forms a kind of miniature solar system. Jupiter resembles a star in composition. In fact, if it had been about 80 times more massive, it would have become a star rather than a planet. On January 7, 1610, using this primitive telescope, astronomer Galileo Galilei saw 4 small stars near Jupiter. He had discovered Jupiter's 4 largest moons, now called to Europa, Ganymede, and Callisto. Collectively, these 4 moons are known today as Galilean satellites. Galileo would be astonished at what we have learned about Jupiter and its moons in the past 30 years. That is the most volcanically active body in our solar system. Ganymede is the largest planetary moon and is the only moon in the solar system known to have its own magnetic field. A liquid ocean may lie beneath the frozen crust of Europa. Icy oceans may also lie deep beneath the crust of Callisto and Ganymede. In 2003 alone, astronomers discovered 23 new moons orbiting the giant planet, giving Jupiter a total moon count of 49 officially named, the most in the solar system. The numerous small outer moons may be asteroids captured by the giant planet's gravity. Saturn. Saturn was the most distant of the 5 planets known to the ancients. In 1610, Italian astronomer Galileo Galilei was the first to gaze at Saturn through a telescope. To his surprise, he saw a pair of objects on either side of the planet. He sketched them as separate spheres and wrote that Saturn appeared to be triple-bodied. Continuing his observations over the next few years, Galileo drew the lateral bodies as arms or handles attached to Saturn. In 1659, Dutch astronomer Christian Huygens, using a more powerful telescope than Galileo's, proposed that Saturn was surrounded by a thin, flat ring. In 1675, Italian-born astronomer Gian Domenico Cassini discovered a division between what are now called the A and B rings. It is now known that the gravitational influence of Saturn's moons, Mimas, is responsible for the Cassini division, which is 4,800 kilometers wide. Like Jupiter, Saturn is made mostly of hydrogen and helium. Its volume is 755 times greater than that of Earth. Winds in the upper atmosphere reach 500 meters per second in the equatorial region. These super fast winds, combined with heat rising from within the planet's interior cause the yellow and gold bands visible in the atmosphere. Uranus, once considered one of the blander-looking planets, Uranus has been revealed as a dynamic world with some of the brightest clouds in the outer solar system and 11 rings. The first planet found with the aid of a telescope, Uranus, was discovered in 1781 by astronomer William Herschel. The seventh planet from the Sun is so distant that it takes 84 years to complete one orbit. Uranus, with no solid surface, is one of the gas giant planets. The atmosphere of Uranus is composed primarily of hydrogen and helium, with a small amount of methane and traces of water and ammonia. Uranus gets its blue-green color from methane gas. Sunlight is reflected from Uranus cloud tops, which lie beneath a layer of methane gas. As the reflected sunlight passes back through this layer, the methane gas absorbs the red portion of the light, allowing the blue portion to pass through, resulting in the blue-green color that we see. The planet's atmospheric details are very difficult to see in visible light. The bulk of the mass of Uranus is contained in an extended liquid core consisting primarily of icy materials, with higher density material at depth. Neptune. The eighth planet from the Sun, Neptune, was the first planet located through mathematical predictions rather than through regular observations of the sky. When Uranus did not travel exactly as astronomers expected it to, a French mathematician, Urbain Joseph Le Verrier, proposed the position and mass of another as yet unknown planet that could cause the observed changes to Uranus' orbit. After being ignored by French astronomers, Le Verrier sent his predictions to John Gottfried Galle at the Berlin Observatory, who found Neptune on his first night of searching in 1846. 17 days later, its largest moon, Triton, was also discovered. Nearly 4.5 billion kilometers from the Sun, Neptune orbits the Sun once every 665 years. It is invisible to the naked eye because of its extreme distance from Earth. Interestingly, due to Pluto's unusual elliptical orbit, Neptune is actually the farthest planet from the Sun for a 20-year period out of every 248 Earth years.
Once known as the smallest, coldest and most distant planet from the Sun, has a dual identity, not to mention being enshrouded in controversy since its discovery in 1930. On August 24, 2006, the International Astronomical Union formally downgraded Pluto from an official planet to a dwarf planet. According to the new rules, a planet meets three criteria. It must orbit the Sun, it must be big enough for gravity to squash it into a round ball, and it must have the way in its orbital neighborhood. The later measure knocks out Pluto, and which orbits among the icy wrecks of the Kuiper belt, the Ceres, which is in the asteroid belt. So this is understood that Pluto takes 248 years to orbit the Sun. Pluto's most recent close approach to the Sun was in 1989. Between 1979 and 1999,
Pluto's highly elliptical orbit brought it closer to the Sun than Neptune, providing rare opportunities to study this small, cold, distant world and its companion moon, Charon. What is Kuiper belt? The Kuiper belt, Keeper, it is pronounced. Belt is often called our solar system's final frontier. This disc-shaped region of icy debris is about 4.5 to 7.5 billion kilometers, 30 to 50 astronomical units from our Sun. Its existence confirmed only a decade ago. The Kuiper belt and its collection of icy objects, KBO, are an emerging area of research in planetary science. No spacecraft has ever traveled to the Kuiper belt, but NASA's New Horizons mission, planned to arrive at Pluto in 2015, might be able to penetrate further into the Kuiper belt to study one of these mysterious objects. Dwarf planets A and Cot. Dwarf planet and Cot is a celestial body that is in orbit around the Sun, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, nearly round shape, has not cleared the neighborhood around its orbit, and is not a satellite. In addition to the 8 traditional planets, there are several dwarf planets in the solar system. Like the 8 main planets, they are round and orbit the Sun. However, what makes them dwarf planets is their size and also the fact that they haven't cleared the neighborhood of their orbits. This could mean that they orbit the Sun in an asteroid belt, or the route they take around the Sun crosses the orbit of another object also orbiting the Sun. The most famous dwarf planet is Pluto, which since its discovery in 1930 was recognized as the 9th planet in the solar system until being reclassified in August 2006. Other objects recognized as dwarf planets are Ceres, which orbits the Sun between Mars and Jupiter, and Haumea, Makemake, and Eris, which, like Pluto, orbit the Sun beyond Neptune. Accompanying the Earth on its journey around the Sun is the Moon, Earth's only natural satellite. The Moon is the second brightest object in the sky after the Sun and is thought to have formed from the debris when a planetary-sized object collided with Earth billions of years ago. The Moon is larger than dwarf planet Pluto and is the only object other than Earth to have been stepped on by human beings. Although the Moon's appearance changes due to its phases, you are only ever able to see one side of it as it always faces Earth. Stars are massive balls of gas that produce heat and light. The Sun is the nearest star to Earth, but it is just one of billions of stars in the Milky Way galaxy, and the Milky Way is one of billions of galaxies in the universe. Although stars are many, many times larger than Earth and often much larger than the Sun, they appear as small dots of light in the sky because they are so far away. Stars can be different sizes and different colors, which tell us a lot about their age and temperature. Comets are often described as dirty snowballs. They are balls of rock and ice which formed in the outer edges of the solar system beyond the orbit of Pluto in a cloud of condensation called the Oort cloud. A typical comet is about 20 kilometers in diameter. Comets orbit the Sun in elliptical orbits, traveling from a great distance to become very close to the Sun. They spin around the Sun and are then flung back outwards. When a comet is close enough to the Sun to be affected by its heat and radiation, it begins to burn off gas and dust and forms a bright tail. Some comets take thousands of years to orbit the Sun, some take a few years, and some are thrown out of the solar system for good after they spin around the Sun. Asteroids are small lumps of rocks and ice which orbit the Sun like mini planets. They are sometimes called planetoids because they were probably formed in the same way as the planets. Some people believe that different seasons happen because sometimes the Earth is farther from the Sun and sometimes it is closer. But it is not true. The Earth travels around the Sun in an almost perfect circle. It is only slightly elliptical. The most accurate way to draw the Earth's path around the Sun is a circle. So it really does not change by much how far away we are from the Sun. The Earth's axis is tilted about 23.5 degrees, so the Earth is never straight up and down compared to the Sun. During the summer, the Sun is high in the sky. Therefore, rays of light from the Sun hit us more directly during summer, making the sunlight more intense and warmer. In winter, the Sun is low in the sky. The rays of light are spread more thinly and they do not warm us as much. Welcome to Dr. Jaya's virtual school. Lloyd, Level 5, Science. Academic Week 11, Science. Earth's layers. Earth's layers, all depths are from the surface of the Earth. The crust. The outer skin of the planet is composed of igneous, metamorphic, and sedimentary rock. The crust is divided into continental or oceanic based on composition and formation. Continental crust, comprised predominantly of rocks most resembling granite. The continental crust is relatively thick compared to the oceanic crust, with a depth that ranges from 30 kilometers to 50 kilometers. The average specific gravity of continental crustal rock is 2.7. Oceanic crust. At an average depth of 5 kilometers to 10 kilometers, the oceanic crust is thinner than the continental crust. Oceanic crustal rocks are composed mainly of the igneous rocks, basalt, diabase, and gabbro, which are mafic in composition. The average specific gravity of oceanic crustal rock is 2.9. The mantle. The layer directly below the crust, which is delineated from the crust by the Mohorovicic discontinuity, where seismic waves increase in velocity. The division between the mantle and the crust is a chemical one, the rocks and constituent minerals being higher in magnesium and lower in silicon and aluminum than crustal rocks. The mantle comprises 84% of Earth's volume. The mantle can be further divided The mantle is further divided as upper mantle, which is lithospheric. The uppermost mantle consists of hard rock and is attached to the crust and comprises the lithosphere. The lithosphere is comprised of tectonic plates which float independently of each other. The lithosphere contains more mantle than crust. The oceanic lithosphere ranges from 5 kilometers to 100 kilometers in thickness, and continental lithosphere ranges from 40 kilometers to 200 kilometers. Asthenosphere. Just below the lithosphere lies the asthenosphere, an average of highly viscous and solid rock. Its viscosity allows it to move slowly over time, which it does as it transfers heat to the lithosphere via convection currents. These convection currents are responsible for the movement of Earth's tectonic plates. The depth of the asthenosphere averages somewhere between 100 kilometers and 200 kilometers, with depths up to 410 kilometers. Transition zone. The depth of the transition zone is between 410 kilometers and 660 kilometers. The rock here is mostly peridotite, a coarse-grained igneous rock kept from melting by extremely high lithostatic temperatures. Temperatures in the transition zone range from 1400 degrees centigrade to 1600 degrees centigrade. The lower mantle. The depth of the lower mantle ranges from 670 kilometers to 2798 kilometers. Little is known about the lower mantle other than the seismic waves indicate it is fairly homogeneous in lithology. The D area of the mantle extends from 2798 kilometers to 2900 kilometers, which is the boundary between the mantle and the liquid outer core. At this level, the pressure are enormous, roughly equal to 1.4 million units of atmospheric pressure, and temperatures are over 4000 degrees centigrade. The outer core. The outer core lies at a depth from 2,900 kilometers to 5,150 kilometers. It's composed of liquid iron and nickel along with small amounts of lighter elements, with temperatures ranging from 4,000 degrees centigrade to 6,100 degrees centigrade near the boundary with the inner core. The inner core. From the boundary with the outer core to the center of the Earth, a distance of about 1220 kilometers, is the solid sphere of the inner core, a ball of incredibly hot iron nickel alloy. Temperatures here reach between 5,000 and 7,000 degrees centigrade, and pressure are calculated to be around 3 lakh units of atmospheric pressure. Despite the higher temperature at these pressure, the metals that exist there cannot remain molten. Earth is made up of 4 different layers: the inner core, mantle, and crust. Creating a drawing of the layers of the Earth is so simple. It is literally a circle within a circle within a circle. To spice up the drawing, fill in the different layers with bright colors and different textures to emulate what each layer is made of. How to learn the Earth's layers? Imagine what would you see if you dug a giant hole all the way to the other side of the earth. You would cut through the crust, mantle, and outer and inner core layers. You will study the earth's layer as well as other earth science concepts, including the earth's magnetic field, plate tectonics, earthquakes, and volcanoes. Learn the names of the earth's layer and where they are located by constructing a clay model of the earth. Instructions. Roll red modeling clay into a ball that measures 1.2 centimeters in diameter using the metric ruler to ensure it is the correct size. The red clay ball represents the Earth's inner core. Modeling clay
with a 3 centimeters diameter. Flatten it into a circle and surround the red inner core with an orange outer core.
Build a 6 centimeter ball of tan modeling clay to represent the Earth's mantle. Flatten it into a circle. Surround the orange outer core with the tan mantle. To make the Earth's crust, flatten a piece of the blue modeling clay and wrap it around the tan mantle, making it as thin as you can. Flatten some green modeling clay to make the basic shapes of the continents and lay them on the top of the blue water. Cut a slice out of the upper half of the earth and cut the earth in half to see the inner layers. Compare the depth of the crust made of blue and green modeling clay on your model. The layer of the earth that you are standing on is the crust, and compared to the other layers of the earth, it is very thin. Under the oceans, the depth of the crust is about 5 kilometers. Under the continents, its depth average is 30 kilometers, and under large mountain ranges, it can reach 100 kilometers deep. Locate the tan layer on the modeling clay, earth. This represents the mantle, a thick layer of hot, semi-solid rock that lies beneath the crust. The mantle is about 2,900 kilometers deep. Pressure causes the mantle to be hotter and denser than the crust. The deeper below the crust, the more the pressure and temperature increases. Examine the last two layers made of orange and red. The Earth's core lies at the center of our planet and is made of two layers, the outer core and the inner core. The outer core layer, represented by the orange modeling clay on the model, is liquid iron and very thick, about 2020 kilometers. Locate the inner core and red modeling clay. Earth's inner core is solid iron and 1250 kilometers in diameter. The magnetic field of the Earth is created as the inner core spins with Earth's rotation inside the liquid outer core. Scientists now believe the inner core may be composed of two layers too. So dear friends, now learn it while doing. Make Earth's layers. Welcome to Dr. Daya's virtual school. Like Level 5 Science. Academic Week 12 Science Simple Machines. Simple machines. Ancient people invented simple machines that would help them overcome resistive forces and allow them to do the desired work against those forces. A machine is a device that helps make work easier to perform by accomplishing one or more of the following functions: transferring a force from one place to another, changing the direction of a force, increasing the magnitude of a force, or increasing the distance or speed of a force. Mechanical advantage. It is useful to think about a machine in terms of the input force, the force you apply, and the output force, force which is applied to the task. When a machine takes a small input force and increases the magnitude of the output force, a mechanical advantage has been produced. Mechanical advantage is the ratio of output force divided by input force. If the output force is bigger than the input force, a machine has a mechanical disadvantage greater than 1. If a machine increases an input force 10 pounds to an output force of 100 pounds, the machine has a mechanical advantage of 10. In machines that increase distance instead of force, the mechanical advantage is the ratio of the output distance and input distance. So, mechanical advantage is equal to output by input. No machine can increase both the magnitude and the distance of a force at the same time. Have few or no moving parts, simple machines make work easier, can be combined to create complex machines. 6 simple machines are lever, inclined plane, wheel and axle, screw, wedge and pulley. So the 6 simple machines are inclined plane, wedge, screw, lever, wheel and axle and pulley are discussed here. Here are some terms that makes you easy to understand. Inclined plane, flat slope surface. Wedge, device that is thick at one end and tapers to a thin edge at the other end. Screw, inclined plane around a cylinder. This spiral inclined plane forms the threads of a screw. Levers, rigid bar that is free to pivot or rotate on a flat point. Fulcrum, the fixed lever point that a lever pivots around. Types of levers, the first class, second class and third class levers. The first class lever always change the direction of the input force. Second class lever increase force but do not change the direction of the input force. Third class lever increase distance but do not change the direction of the input force. Wheel and axle, made of 2 circular or cylindrical objects fastened together that rotate about a common axis. Pulley, made of grooved wheel with a rope or cable wrapped around it. Types of pulleys: fixed pulley, movable pulley and block and tackle. Fixed pulley does not change the amount of force applied but changes the direction of the force. Movable pulley decreases the amount of input force. Indeed, it does not change the direction of the force. Block and tackle pulley, both fixed pulley and movable pulley mixed. Compound machine, a machine that utilizes 2 or more simple machines. 6 types of simple machines are then: inclined plane, wedge, screw, lever, wheel and axis and pulley. So let us discuss in detail what are these. Inclined pulley. Inclined planes are a slope or ramp that goes from a lower to higher level. Makes work easier by taking less force to lift something a certain distance. Trade-off: the distance the load must be moved would be greater than simply lifting it straight up. Mechanical advantage: inclined plane is the mechanical advantage of an inclined plane is the length of the slope divided by the height of the plane. If effort is applied parallel to the slope, so for our plane, so mechanical advantage is equal to length of slope by height of plane. So 15 feet by 3 feet, so it will be 5. So let's say S is equal to 15, H is equal to 3 feet. A wagon trail on a steep hill will often traverse back and forth to reduce the slope experienced by a team pulling a heavily loaded wagon. This same technique is used today in modern freeway which travel winding paths through steep mountain passes. Wedge: an inclined plane on its side used to cut or force material apart, often used to split lumber, hold cars in place, or hold materials together. The wedge is a modification of the inclined plane. Wedges are used as either separating or holding devices. A wedge can either be composed of one or two inclined planes. A double wedge can be thought of as two inclined planes joined together with their sloping surface outward. Mechanical advantage of wedge: much like the inclined plane, the mechanical advantage of a wedge is the length of the slope divided by the width of the widest end. So, mechanical advantage is equal to length of the slope by thickness of widest end. So, for our wedge, say mechanical advantage is 6 inches by 2 inches, that is 3. They are one of the least efficient simple machines. The lever. A lever is a rigid bar that rotates around a fixed point called the fulcrum. The bar may be either straight or curved. In use, a lever has both an effort or applied force and a load resistant force. Three classes of levers. The class of a lever is determined by the location of the effort force and the load relative to the fulcrum. Lever: a rigid board or rod combined with a fulcrum and effort. By varying position of load and fulcrum, load can be lifted or moved with less force. Trade-off: must move lever large distance to move load small distances. There are 3 types of levers. To find the mechanical advantage of a lever, divide the output force by the input force, or divide the length of the resistance arm by the length of the effort arm. The first class lever. In a first class lever, the fulcrum is located at some point between the effort and distance. Resistance forces. Common examples of first class lever: inclined crowbars, scissors, pilers, tip snips, and seesaws. A first class lever always changes the direction of force. that is downward effort force on the lever, results in an upward movement of the resistance force. Fulcrum is between EF, effort, and RF, load. Effort moves further than the resistance, multiple EF, and changes its direction. The first class lever, the fulcrum is located between the effort and the load. So direction of the force always changes. Examples are scissors, pilers, and crowbars. Second class lever. With the second class lever, the load is located between the fulcrum and the effort force. Common examples of second class levers include nutcrackers, wheelbarrows, doors, and bottle openers. A second class lever does not change the direction of force. When the fulcrum is located closer to the load than to the effort force, an increase in force, mechanical advantage, results. RF, load is between fulcrum, and EF, effort moves further than resistance. Multiples EF but does not change its direction. Second class lever, the resistance is located between the fulcrum and the effort. Direction of force does not change. So examples include bottle openers and wheelbarrows. Third class lever. With the third class lever, the effort force is applied between the fulcrum and the resistant force. Examples of third class levers include tweezers, hammers, and shovels. A third class lever does not change the direction of force. Third class levers always produce a gain in speed and distance and a corresponding decrease in force. EF is between fulcrum and RF, load does not multiply force. Resistance moves further than effort. Multiples the distance the effort force travels. So the third class lever gives the effort is located between the fulcrum and the resistance. Direction of the force does not change, but a gain in speed always happens. So examples include ice tongs, tweezers, and shovels. Mechanical advantage of third class lever. We know that a machine multiplies whatever force you put into it. Using a screwdriver to turn a screw, twisting a nail with pliers, carrying a box upon a ramp instead of stairs. The amount that the machine multiplies, that force is the mechanical advantage of the machine, abbreviated as MA. IMA is the ideal MA. This is the MA of a mechanical machine in a world with no friction and no force is lost anywhere. AMA, actual mechanical advantage. This is simply the mechanical advantage of a machine in the world as we know it. Force is lost due to friction. Force is lost due to wind. Can we have an ideal machine? The mechanical advantage of a lever is the distance from the effort to the fulcrum divided by the distance from the fulcrum to the load. So, it is mechanical advantage is equal to MA is equal to distance effort minus fulcrum by distance load minus fulcrum. For our example, MA is equal to 10 by 5 is equal to 2. So distance from effort to fulcrum 10 feet. Distance from load to fulcrum is 5 feet. Wheel and axle. A large circular wheel affixed to a smaller rigid rod at its center, used to translate force across horizontal distances, wheels on a wagon, or to make rotations easier. Trade-off: the wheel must be rotated through a greater distance than the axle. Mechanical advantage of wheel and axle. The mechanical advantage of a wheel and axle system is the radius of the wheel divided by the radius of the axle. MA is equal to radius of wheel by radius of axle. So for our wheel and axle, MA is equal to 10 by 2 is equal to 5. Wheel and axle. The wheel and axle is a simple machine consisting of a large wheel rigidly secured to a smaller wheel or shaft called an axle. When either the wheel or the axle turns, the other part also turns. One full revolution of either part causes one full revolution of the other part. Screw. An inclined plane wrapped around a rod or cylinder used to lift material or bind things together. Mechanical advantage of screw. The mechanical advantage of a screw is the circumference of the screwdriver divided by the pitch of the screw. The pitch of the screw is the number of threads per inch. MA is equal to circumference of screwdriver by pitch of screw. So for our screwdriver, it will be MA is equal to 3.14 by 0.1 is 31.4. Circumference and pitch. The screw is also a modified version of the inclined plane. While this may be somewhat difficult to visualize, it may help to think of the threads of the screw as a type of circular ram. Pulley. A pulley consists of a grooved wheel that turns freely in a frame called a block. A pulley can be used to simply change the direction of a force or to gain a mechanical advantage depending on how the pulley is arranged. A pulley is said to be a fixed pulley if it does not rise or fall with the load being moved. A fixed pulley changes the direction of a force, however, it does not create a mechanical advantage. A movable pulley rises and falls with the load that is being moved. A single movable pulley creates a mechanical advantage, however, it does not change the direction of a force. The mechanical advantage of a movable pulley is equal to the number of ropes that support the movable pulley. Pulley, a rope or a chain free to turn around a suspended wheel. By pulling down on the rope, a load can be lifted with less force. Trade-off, no real trade-off here. The secret is that the pulley lets you work with gravity, so you add the force of your own weight to the rope. Mechanical advantage. Pulley. Mechanical advantage of a pulley is equal to the number of ropes supporting the pulley. So for the pulley system, you can have 3 ropes supporting the bottom pulley. Mechanical advantage. This means that if you pull with a force of 20 pounds, you will lift an object weighing 60 pounds. The trick is work. Simple machines change the amount of force needed, but they do not change the amount of work done. So what is work? Work equals force times distance. So W is equal to F and D. By increasing the distance, you can decrease the force and still do the same amount of work. Efficiency. We said that the input force times the distance equals the output force times distance. So input force into distance is equal to output force and distance. However, some output force is lost due to friction. The comparison of work input to work output is called efficiency. No machine has 100% efficiency due to friction.